All, and as you can see in this thumbnail, if we'll calculate g of pi by 12, by definition it's pi by 12 2 pi over 4 cot inverse 2 minus 10x dx. Now somehow I have to relate this with g of pi by 3, which becomes pi by 4 to pi over 3 cot inverse 2 minus 10x dx. So basically, as you can see in both problem, only limit of integration is different. Rest we need to relate these two values. Now one way of doing this is to just evaluate them independently, and with the hope like maybe in some step they can be connected. The other hint is available in the picture because pi by 4 is common, and pi by 3 and pi by 12 feels linked because you see 10x, suppose if I make a substitution, just feeling I'm telling. So 10 pi by 12 is going to be 2 minus root 3. This you can calculate separately also with 1030. Okay. So somewhere 2 minus 10x is there in the argument. So 2 minus root 3 motivates us of bringing root 3 into picture, which is basically 10 pi by 3. So maybe one way of doing this will be to make a substitution 2 minus 10x equals 10 theta, and that can, like relate these two integrals, and possibly we don't have to find anything. So with that motivation, we'll do this. Or the other way is to use integration by parts. So what I'm doing is I'm using integration by parts on g pi by 12. So with 1 as the first function and f of x as second. So we'll leave cot inverse 2 minus 10x, integrate 1, which is x, evaluated from pi by 12 to pi by 4, minus differentiate cot inverse that and leave that. So we are having pi by 12 to pi by 4 x secant square x, and cot inverse something is 1 plus 2 minus 10 of x whole square. Right, minus will come because 2 minus is minus, and cot inverse x derivative is minus 1 by 1 plus x square. So minus minus plus, and this minus is because of integration part. So effectively we have minus sign only. Ab isko again we know like this quantities can be evaluated very easily. At pi by 4 it's giving cot inverse 1 into pi by 4, so that gives pi by 4 whole square. At pi by 12 cot inverse 2 minus root 3 is cot inverse root 3, which goes to pi by 6 and into pi by 12. So this quantity is fine. We have 7 pi square by 144, right? So this quantity becomes 7 pi square by 144. Now just we need to calculate the second integral. Second integration I can make a substitution 1 minus 10x equals, let's say, 10 theta. This motivation as I have already told you in the beginning, right? So with this motivation, this substitution brings this into pi by 12 gets converted to 2 minus pi by 12 means 2 minus root 3. So that becomes pi by 3, and pi by 4 is still pi by 4. And we have denominator as 1 plus 10 square theta x times secant square x dx. We can write 10x as 2 minus 10 theta. So secant square x dx is minus secant square theta d theta. So plotting this value, okay, this given integral evaluates to minus times of secant square theta d theta into x. Now secant square and 1 plus 10 square gets kicked off. We have minus of pi by 3 to pi over 4, and x, as you can see, is tan inverse 2 minus 10 theta d theta. So this limit became pi by 4 to pi over 3 tan inverse 2 minus 10 theta. And since minus is already there in front, so overall the second term, finally I am getting 7 pi square by 144, and minus of pi by 4 to pi over 3, that quantity, right? So minus of pi by 4 to pi by 3, this expression. Now still there is a small thing left because I wanted cot inverse something to come into picture. And as you can see in this interval between pi by 4 to pi by 3, this quantity is anyway going to be positive. So tan inverse positive x plus cot inverse x is anyway pi by 2. In fact, it's true for all interval of x when it is different. But यहाँ पे specifically we can tell, like we'll get pi by 2 minus cot inverse tan inverse cot inverse of 2 minus tan theta, right? By this transformation formula, 2 minus tan theta, this theta. And now that solves the problem because we have g of pi by 12 equals this one, 7 pi square by 144 minus pi over 2 pi over 4 to pi over 3 theta, and that's plus, and that's nothing but a definition of g of pi by 3, right? So evaluating this, 7 pi square by 144 minus pi over 2 into pi by 3 minus pi by 4, so that will give pi by 12 and plus g pi over 3. So we have 144, and this quantity evaluates to 4 pi minus, so pi is square root of 24, right? So this we can actually multiply because 24 by 3, which finally evaluates to g of pi by 12 minus g of pi by 3 equals pi square by 144. So this was a good question on which we can actually find this. So this was a good question, and you can see like how integration by parts has helped us, and the idea of connecting the limits when the function is the same. Thank you. Have a good day. 0 to pi greatest integer cos x. One way of doing is you can graph and find the area. Other way is you can replace x with cos of pi minus x using King's rule. And now this becomes 0 to pi greatest of cos of pi minus x is minus cos of x dx. And let's add both. So 2y is 0 to pi greatest cos greatest minus cos dx. And now we know this quantity will be either 0 or it's going to be minus 1. Since 0 will come at discrete point, because if we'll take greatest x plus greatest of minus x, takes x as integer, you'll get 0. If x is not integer, we'll get x is not integer, then you get minus 1. For x integer, you get 0. Since 0 will come only at discrete points, so it will not impact the area, okay? Because when you calculate some area, just taking away one single point or slice will not impact the area until it is infinitely many, because then turning 0 into infinity may contribute. So hence I can tell this is, you have understood this. Thank you. Have a good day.